So hello everyone. Today we are going to solve leetcode today's question. So तो start करते हैं. तो हमें एक binary string दिया गया है, which is named as boxes. So it will be boxes. And what is it? Let's take example number 2 because it's bigger. 0 0 1 0 1 1, and we have to calculate for every index. Like मैं अगर बताऊँ आपको तो let's say we are at index this one. So let's draw our index as well. 0 1 2 3 4 and 5. ओके हमें हर इंडेक्स के लिए मूव्स कैलकुलेट करने कैसे. लेट्स से this is the box and we have to put all the ones in that box, and putting that ones into that box, how many number of moves required. Let's say we have to put this one into this box, then how many moves required. Like in one moves you can just go to its adjacent, like for this one go to its adjacent and then go to its adjacent. It will require two moves. You can directly calculate it. Like how? Let me show you. What is the index of this. Like it has a 4 and it has a 2, so moving from 4 to 2, 4 minus 2 will be take 2 moves required. Okay, let's just calculate for this one. And this has an index 5 and moving to 2, so it will be minus 2. 5 minus 2 will be 3. And there is one more one here, which is already present inside that box, and this will take, like, what are the number of moves it will take. It is present on 2 and we have to move it on 2. It will take 0. So this one required moves 0, so we will calculate total number of moves required by all ones to move that index. It will be 3 plus 5, it will be 5. So similarly we have to calculate for every index and we have to return an array. Okay, I hope this makes sense. And let's just the brute force approach is very simple. Like go to every element, like go to every index. Let me show you. Go to this index and calculate. Go to from left to right and calculate absolute difference between I minus j. Or I is an index, current index, which is this red one showing current index, and j is moving from 0 to length of the array. Okay, and for every element, every index, go to and just calculate the or whatever moves required to move all ones to that particular index. I hope this will make sense. And if you want, let me just write a quick pseudocode for it so that you can understand it better. Like we have to maintain an array and we have to return an result. So let me make it vector of int. Let's call it result. And for I equal to 0 to n, and then let's just make moves. What are the moves required for a particular index? Then for j equal to 0 to n, we will just see if my boxes of j, if it is 1, then we will calculate its move. Like how moves will be plus or equal to abs of, that means absolute difference between I and j. And that's it. After this loops end, I'll just push the moves. We will push back moves into my result, and after this loop I am just returning result as my answer. So the time complexity will be taken by n square. And if you see the constraint of this question, it will be n is up to 2000. So for that it will accept it, like big O of n square going to be accepted. So this is the brute force. Let's discuss how we can optimize it. It is brute force, and let's see the optimization of it. Okay, let me erase this thing. In optimization, we just pre-compute it for left to right and right to left. So we will go left to right and right to left 2 times. And going left to right means that we have to calculate, say I'm at current index 2 and I'm just calculating what are the number of ones present inside in the left section. This is the left section, and whatever the number of one present and what are the minimum number of one moves required to move all the ones which is present on the left side. at index 2. So let's just take another example. Let's just close this thing, and I am at index 3 now. This the left section we have is this one. This is the left section. Let me mark it, and there is only one present which I have to move. And then what are the number of moves required to move this one? It will be 1. So for calculating left to right, it means we are calculating what are the number of moves required to move all the ones which is present on the left side to that particular index. Okay, so how we are going to do that? And this is very similar to the right. Like if we calculate from right, we will calculate like how many numbers of this is my, let's say this is my current index, and uh, this is my left section, and how many number of moves required to move all the one which is present on the right side at index 2. So if you can see, this is the one, and we have to move here, so it will take 2 moves, and this will take 3 moves. So total we have 5 moves. So we have 5 moves required to move all the ones present on the right side to the index 2. Now I hope you will understand, you have understood. Now, okay, how we are going to do, I am explaining from left to right, and this is same for right to left. So we will maintain a variable called left one. It just count how many one present on the left side. Initially it is 0, and moves, how many moves required to move all the ones to the current index. Okay, let's just erase this thing, and let's say we are at index this one, so my left half is, there is nothing. So let's say res I will be this one. Okay, so 0 1 2 3 4 and 5. Okay, initially it is 0, so we will mark it as 0. So I equal to 0, nothing happened. Now I'll go to the next index, so my left half will become this one. So there is one element which is 0, so there is no one, so we will just move and put the moves, whatever moves we have, like moves is 0. Now go to its next, it will be this. My left half becomes these two elements, there is no one present, so just put moves here and move to the next part. Okay, as you can see, at index 2 there is one present, so we will update my left one will be 1. Now what are the moves required for index 3? We are currently at index 3. Let me write it. I equal to 3. We are currently at index 3, and as you can see, in the left side there is one present. And what are the number of moves required to move this one uh, to the index 3? It will be moves plus or equal to left 1. These many moves required, like in this case, moves will be 0. So 0 plus what are the left number of ones present on the left side? It will be 1, so it will be 1. So I'm updating a result of index 3 with 1. Okay, so let me erase this, all the things. This is 0 0 1. So we have just moved this one to here. Okay, so assuming, मैं assume कर रहा हूँ, ऐसा मूव नहीं होगा, तो ये 0 बन जाएगा और ये 1 बन जाएगा, तो ऐसा कुछ दिखेगा. ठीक है, हम अभी इंडेक्स 4 में हैं, at index 4, and my left half will become like this. My left half looks like this. Okay, as you can see, there is only one element, one present at the left side, and we have to move this one. How many moves required to move this one to the, at the fourth index? It will be whatever, it will be 1. So पहले से जो भी moves था, it will be 1 and plus 1. Okay, so the moves required, it will be 2. So I am updating 2 here. Now let's just erase, and हमने इसको, इस 1 को हमने इधर मूव कर दिया है. ठीक, तो इसका मतलब क्या है कि हमारे पास 2 मूव हो जाएंगे, 2 1 हो जाएंगे. सो इसका मतलब ये है कि ये 0 हो जाएगा, यहाँ पे 2 मूव हो जाएंगे, क्योंकि पहले से 1 प्रेजेंट था, अब एक और इधर से आ गया, तो इधर 2 1 हो जाएंगे. नाउ आई एम एट इंडेक्स 5, एंड माई लेफ्ट हाफ विल बी दिस वन. दिस इज and as you can see there is 2 1 present. This is 2 1, and if we want to move this 2 1 to the next to it, how many moves required? पहले से जो moves थे वो तो required होंगे ही, that means 2 तो required हो गई, प्लस बिकॉज यहाँ पे दो 1 प्रेजेंट है, अगर इन दोनों को मूव नेक्स्ट में करना है तो मुझे एक एक करके मूव करूंगा, तो इट विल रिक्वायर 2 मूव्स, सो 2 2 4, देयर इज 4, and we will do the same thing for going uh, right to left. Okay, let's just code it so that you can understand better. Okay, so let me store the length of the boxes into the variable called n boxes dot size. Now we will just declare a vector res result. It has a size of n, initially mark it at 0. Now we will initialize a left one as 0, and moves will be 0. Now for int I equal to 0, I is less than an I plus plus. Okay, so rest of I will be plus or equal to moves. Now we will if the boxes of I will be 1, then we will increase my left 1 by 1, and moves will become equal to left 1. Okay, we will do this exact same thing. Let me copy this and paste here for the right half. In this case, we will create a variable called right 1. Initially it is 0, and let me reset the moves to 0. Okay, move same, then stay right 1, and we will iterate from n minus 1 to I is greater than or equal to 0, I plus plus, I minus minus, sorry. And this is right 1, and yeah, after that I'm just return result. Let's run this, and it is accepted. Let me try to submit this. Okay, all right, so the time complexity it will take big O of big O of n, 2n you can say, because we are iterating twice from left to right and right to left, and it is approximately big O of n. Okay, so what is the space complexity? Space complexity it will take big O of 1, and if you are asking like we are using the a vector of size and why it not, because it is accepted, because we have to return this answer, and that's why we have to creating this answer. So it will not consider into space complexity, so it will be big O of 1. So that's it, मिलते हैं अगले वीडियो में.